Locations are becoming extremely important in today's app development world. Be it nearby application where you want to see what are the nearby petrol pumps, or you are having a food delivery app and you wanting to see what are the best food options available nearby, or you are tracking a rider or a driver of your cab service and you want to see where they are located. So in all of these cases you would need location, and you would need the location service to be fast as well. That is, you would want to have frequent updates of their location and frequent get and put operation on those. So in this video I'm going to talk about location and how you can integrate the location in your system and how do you store it and query it. Let's quickly get started. What I'm going to solve in this video is the aerial distance. So for example, here you see I am in my home and I'm searching for Chinnaswamy Stadium, which is in Bangalore. You can see that it is 9.3 kilometers from my place, but this is the aerial distance. There is another problem statement in which it actually tracks down the road and figures out what is the best path to reach the stadium. But that's a separate problem statement where you are trying to figure out the best path to reach. So we are not solving this today. We are solving the aerial distance. And in most of the applications which you will see, for example, the nearby application where you create a circle and try to see what are the places located near to you, in most of the cases this is also used and this is also used, and somewhere the combination of two is used. So today we are going to talk about the first one, that is how do you get the aerial distance from place 1 to place 2. So it might look simple, that but that's not the case. So if this is the problem statement which we are going to see, you have a front end, you have mobile app, iPad or a laptop, and there is a backend, and you want to know the electric charging location within the 5 kilometer of radius. A very common problem statement. In many places you would need them. So if you divide this problem statement, you can divide the problem statement into multiple subsections. One is, how do you store latitude and longitude? Would you store in a string, or is there a separate data type to deal with that? What is the aerial distance between the 2 points? That is, if the point is here and the here, then you would need the aerial distance between the 2 points. As already we talked about, we are not talking about the road and how the shortest path would look like. Basically the aerial distance and the locations in the radius. So this statement, this one and this one, the second and third, they are related. So if you solve this one, you can solve the other one as well. And eventually we'll talk about the limitations as well. So whatever approach we discuss, it will have some limitations, so it will work in most of the cases. In fact, almost all the practical use cases. But good to have those limitations in place so that you know what you are going to deal with. So if you consider Earth as a flat surface, so if you consider the Earth as flat and say, hey, there is a latitude, there is a longitude. Latitudes are from minus 90 to 90. That is, they start from the bottom and then they reach zero and then they go up. So from south to north, minus 90 to 90, and then there are longitudes. These are the vertical lines, and they start from minus 180 to plus 180 degree. So that's how the grid-like location of any map looks like. And if you consider Earth as flat, and that holds true for a shorter distance. So let's say if you are calculating distance within a city or quite shorter distances, this formula would hold true, that you have coordinates 0.1 here, 0.2 here, 0.3 here, and essentially if you need the distance between 2 points, let's say C and D in this case, you can actually create a right angle triangle and calculate the hypotenuse of that triangle with a simple formula, as you can see here. But the problem is that it holds true only for the smaller distance. It doesn't work for the larger distance. So we are not going to take this as a choice, and nobody takes this as a choice when they are building a system. They generally take the other approach. So what is the other approach? Other approach is to consider Earth as a sphere. So that's how it is, that Earth is a sphere. And now this is no longer a right angle triangle. In fact, the the edges are curved. So in that case, it becomes a mathematical formula. This is the Haber-Sine formula using which the calculations are done, and eventually they reach to this formula, that is 2r arcsine, where r is the radius of the Earth, and then you can see longitude and the latitude which is there. So with the help of this, you can calculate the distance between point A and point B. So this is longitude 1 minus longitude 2 by 2, and here the latitude is there. So using this, you can calculate the distance, and this works fairly well. And this is the approach which is being used by multiple systems. So today also, the system which we are going to talk about will use this Haber-Sine formula. It works very well. So it assumes that Earth is spherical, spherical shape. So since Earth is actually not spherical, it is ellipsoid, that is, it has a radius which is lesser in the pole and more in the equators. So it takes that approximation. But if you see the data, you would find that the diff is not much. So in most of the cases, you can actually consider the Earth to be spherical, but that will give you the max error of 0.55%, and in most cases it will be just 0.3%. So in when you are measuring in terms of kilometer, you would find that in while measuring 1 kilometer of distance, you would find the error of around 3 meters in general, which is acceptable in most of the cases. But if it is not acceptable for you, there are other systems and there are other mathematics which are there to solve it, and I'll link them in the description. You can feel free and check out them as well. So if you take the radius of the Earth at the poles, so the radius of the Earth at the pole is 6357 kilometer, and the radius of the Earth in the equator, it is 6378 kilometer. So you can see the diff is not much. So that's the reason in most of the cases it's okay to take the Earth as a sphere. You would get this error, but if that error is acceptable for you, you are good to go. Now let's move to Redis. Geolocation using Redis. So Redis is by far the best choice you can make to integrate your system with Redis. The reason is that if you see, almost all organization or many of the organization, to give some approximation, they use Redis in one or the other way. They would have a Redis in their company and the services would be already interacting with Redis. So in that way, Redis has an edge. You don't have to integrate a new service or new database. And it also has the facility of persisting in the background. It is in memory, so it is fast, and people can update as well as get the operation very fast. So that's how the advantage of Redis is. And yes, it uses the Haber-Sine formula, which we talked about. It considers Earth as a complete perfect spherical ball, and it supports the longitude from minus 180 to 180. That is, from left to right, it covers the complete minus 180 to 180 degree. However, it's the latitude supported are minus 85 to 85. So it does not cover this area, the top area as well as the bottom 5 degree. So these two places it is not covering. It follows some of the standards using which it is not being covered. I'm not sure what the standards are and why it chose not to support it, but definitely in most of the cases you would be good to go if you ignore these 5 degree for here and 5 degree for here. Otherwise you can always go ahead and use other systems, but for the remaining of the Earth, that is wherever the humans generally live, you are good to use Redis. It will support the formula, it will give the precise distance, and you can use it extremely easy. It was quite simple for me to use it. And here are the operations which are supported in Redis. So you can add a geolocation. Of course, you can do the CRUD operations. So you can add a geolocation to the Redis, and then you can find the distance between two places. Very in a very simple method, you can give the location 1, location 2, and you can find the distance. You can find the geo hash. So you can take a hash of a location and keep in dependent services so that you don't have to call them. Geoposition is, it you give a key and it gives you the lat long. And the most important, geo search and geo search store. So you can search by radius. So you give a center in a map, and then you can ask, give me all the locations in a given radius. And likewise, by box, you have a center and you can ask, give me all the locations in the box. There is one thing to notice is that this alignment of the box is not configurable. So for example, if you give this as an input, that here, this is the location, give me all the locations in this rectangle. So this rectangle can't be rotated. You can't get the output for something like this. You would need the box to be straight. So in this way, that's one limitation again, which you would need to work around. And but I would say that in most of the cases, you are good to go for circular as well as rectangle. These two things will cover most of the cases. You would in general not need a complex objects, but in case you do, for example, if you want to have a periphery of a shopping mall or a complex area and you want to know all the places within that complex area, in such cases Redis will not be much of a help. You might have to break down that complex area into smaller rectangles and then make multiple calls to Redis and then maybe take the unions. But that's a hacky way to do it. By default, you would have the support for circles and rectangles, which can solve almost all the use cases which you would generally see. So now let's quickly move on to the computer screen and try out these commands and see how they behave. All right, so now we are ready with the Redis setup. We have a Redis downloaded and installed in our machine. The steps are very much straightforward. You can check out the link in the description to download Redis and then install in Mac, Windows, or Linux. And then I connected using my command line tool to the Redis server. Again, the steps are straightforward. I'll again share the link in the description on how to connect them. So in our demo, what we'll do is we'll have 2 points, 2 coordinates. One is my office location in Bengaluru, and the other is the airport location. And what we'll do is we'll try to do various operations on these lat long coordinates so that you can see how the operations are. So we will be adding those coordinates into the database and then we'll be fetching them. We'll try to see the nearest neighbor equation or the command. So these are the things which we'll try. And this is just online utility maps.co. You can give them the lat long coordinates and they will plot it so that it will be easy for you to observe and see how the coordinates look. So it will be easy to imagine basically how they are functioning. So the first command which we will see is the geo add. So if let's have a geo add command. So geo add actually adds the location. So YT demo 1, and it is basically in the form of longitude and latitude. So added. Now let's add other location, that is airport. So we can add the airport as well. So again, it's in the form of longitude and latitude. Straightforward, nothing specific. So let me do that one here. And then let's try to run command one by one. So the first is geo hash. So geo hash actually gives you the hash of the location. So this is how it's stored and that helps to search as well. So that's the first thing the geo hash. It takes the hash of the coordinates and then stores in itself. The second is geoposition. So if you want to know the position of location, you can run this command. So let's run geopos, and then we'll give yt demo 1, and we want to know the location of our office. So it will give me the longitude and latitude. So simple operation, get input. It won't help much. It is there in almost all databases. The one which adds the fun is the geo search. So what if I want to search something? So for that, if I run this command called as geo search, and let me run it on yt demo 1, because that is our database. So if I run on this, and you can see it's from member office by box. So there are two methods using which you can search. By box means it will create a rectangle with the width as 7. The width will be just 7 kilometer and the height will be 62 kilometers. So by height 62 kilometers, it means that it will create a rectangle, big rectangle with this as the center. So basically around 31 kilometers the aerial distance will be calculated. So if you do this, you can get that the distance is 31 kilometer from this point to this point. But since the rectangle was 62 kilometer large, considering this as a center, it was able to cover and give me this place. So that's how you get the geo search by the box. The other one is by radius. So you can search by radius as well and get the data. So by running this command, if I run this command and I can give yt demo 1, you can see that I am able to get two locations in the 32 kilometer radius. So since it is 31.0015 and I'm considering the radius, I was able to get the location. And the last is around the geostore. So geostore search store is nothing but it is same as the geo search, but what it does is that it takes the output of geo search and puts in a key. So you can give a key so that you can do further operations, and from next time onwards you don't have to actually query the and do the computation. Next time onwards you can just do a get operation on the key. So that's how it will be helpful. So it gives you the geo search store output, and now you can query on the key to get the value. So let me just do one thing. Let me make it key 3 just to have the fresh output, and then I can run this command zrange to give me the output. So whatever was stored in key 3 or key 2, I can get using the zrange command. So if I run this, I can get the value which is stored in this key. So there are two values which are stored. One is office and the other is airport. So overall, with the help of the geo commands of Redis, you can get whatever value you want, and overall it will help you to get the data in a spherical earth. And yeah, to be honest, these distances are quite precise. These are the aerial distances, but honestly, if you are going by road, then you would actually be taking this path over the road, and then from here you would go, of course you will follow the road to go to the airport. So in that case, the distance would increase to around 50 kilometers. So overall, a great tool, a great way to kickstart your based computation and storing the distance in Redis. The basic calculations and the operations which are there. There are a few more operations which are there. You can see them in the documentation, but overall, if you use these operations, these 5-6 operations, you are good to go. So you can integrate these operations into your services, and it will help you to compute the distances between the locations and deal with these problems of the nearby overall. There is this one more command which should be covered is geo distance. So you can write geo dis, and then YT demo 1, that is the key which we were using, and then office airport, we need distance in kilometers. So when you do that, you can get the distance between the 2 points in kilometers. So yes, this is also quite helpful. Thanks everyone for watching this video. In this video, I covered how to store and compute on the location data type. There are many times when we talk about other data types like string and integer, etc. But somehow this data type is missed. So when I was looking for how do you store and how do you solve the problem statements of something like a nearby application, so the first thing which comes is how do you store the location and how do you run these commands. So Redis is one of the easiest solution which you can find. Other solutions are also there, but they try to solve a lot more things than just the requirement which are the common requirement. So in that way it's quite easy for you to ramp up and integrate the location stuff into your services. There are other solutions as well, but yeah, they will require much more effort to get even started. So that's all from my side from for this video. Please like and comment if you really like it. Till the next time, bye.